Apache Pig, a run-through by Aisha Nasir. Data is generated every minute in humongous quantities. Consider the number of tweets on Twitter, or the emails through various service providers, or those text messages you send to your friends. This data can amount to thousands of terabytes or even petabytes. This is big data, and its analysis can be pretty useful to companies to improve operations like personalized campaigns, marketing, and effective business predictions and decisions, thereby increasing their revenues and profits. So, how do you perform these analytics? This is done using the ETL process, extract, transform, load. You extract the data from various globally distributed sources. This extracted data can be in any format, like an XML file, a table, a JSON file, or maybe even a doc file. So, to remove such inconsistencies, you transform this data into something useful. The useful stuff is then loaded into a database like HBase or Oracle Big Data or any other database. However, big data isn't any sort of data. To, to put things into perspective, consider the following example. How big is big data? You have 1664 GB iPhones, and that together make 1 terabyte. And any instance of big data may range up to thousands of terabytes. That's like 16,000 iPhones. And how do you perform ETL on such a large data set? The simple answer is Hadoop. Apache Hadoop. Apache Hadoop, developed by Yahoo and then acquired as an open source framework by Apache, is used for storing and processing big data. It has four components. The components are Hadoop Common, Hadoop Distributed File System, Hadoop MapReduce, and Hadoop Yarn. Hadoop Common contains libraries and utilities required by all other Hadoop modules. The HDFS is a distributed file system that stores data on commodity hardwares, providing high aggregate bandwidth across a cluster. The MapReduce is a program for large-scale data processing, and Yarn is a resource management platform for managing compute resources in clusters and then using them for scheduling the user's applications. Now, Hadoop is based on Java, and it turns out you can write a MapReduce with Java. So for that, you'll need to learn Java, and Java programs, if you know, can get very large and messy with large datasets and complex logics. So Yahoo researchers decided and developed an ad hoc way of creating and executing MapReduce jobs on very large datasets. It is called Pig. Apache Pig. Apache Pig provides a high-level abstraction for processing over MapReduce. From Yahoo in 2006 to Apache Software Foundation in 2007, Apache Pig is an open source framework with its high-level data flow language called Pig Latin. The Pig architecture has four parts: parser, optimizer, compiler, and the execution engine. The parser handles the Pig scripts and outputs a directed acyclic graph. The directed acyclic graph, also known as DAG, is a data flow diagram, and it contains logical operators and the data flow. The optimizer then takes this DAG and logically optimizes by using functions like projection and pushdown. It is then passed onto the compiler, which compiles the script into something known as MapReduce jobs. These MapReduce jobs are tiny programs in MapReduce which can then be executed on the HDFS, and they are passed by the execution engine to the cluster where the processing takes place. Here's an example of the DAG, or the directed acyclic graph. You can see that the first section is divided into several tasks, and when each of them gets completed, the next task, which was dependent on all of them from the section 1, will get executed, and so on and so forth. Notice that instead of a rigid pipeline, we can now include the user's code at any point for pipeline development. So how is pig scripting done? It involves the use of Pig Latin. Pig Latin is a textual data flow language that abstracts the programming from the Java MapReduce idiom into a notation. It is in between the declarative style of SQL and the procedural style of MapReduce. What does that mean? That means that you want to write declarative syntax like how you use the select statements, the insert statements, the load statements in SQL. In that very similar way, you can use group, co-group, for each and all those statements in Pig Latin also, but at the same time you can write procedures or functions as a group of statements that you can convert them back into a MapReduce job and run it on the Hadoop cluster. What that means is that you want to break the rigidity of the MapReduce. MapReduce has a two-step framework which doesn't allow to easily integrate user-defined functions. And Pig Latin treats user-defined functions as first-class citizens. User-defined functions, or UDFs as they call them, are very flexible and dynamic in nature. And Pig Latin takes these flexible entities and treats them in the first class manner. That is, you can use primitives like grouping, filtering, joining, etc. in these UDFs and integrate them into Pig Latin, and Pig Latin then converts them back into MapReduce jobs. And as a result, Pig Latin becomes way more powerful with the thinking of a procedural programmer, and you can convert them and becomes way more powerful than the MapReduce algorithm and the idiom. So we also have another feature of Pig Latin, which is nested data models. Nested data models in Apache Pig are atoms, tuples, bags, and maps. Atoms are simple atomic values such as string or number. Here highlighted in red is Alice, which is a string, which is an atom in Pig Latin. Next we have a tuple, which is a sequence of fields, each of which can be of any data type. That means within a tuple you can have atoms, which can be a string, a number, or something else. And you within a tuple you can also have a tuple which helps you in nesting various tuples and various bags within one another. Now you have a bag, which is a collection of tuples. And think of a bag in the normal use case scenario. You can have several items within a bag, and you can have several duplicates of the same item, and you can have different sizes of atoms. So within a bag in the Pig Latin structure, we have so much flexibility that we can have several duplicates of the same tuple with varying sizes. Sizes can be one or anything else, and you can have a bag. Here we have a tuple inside a bag, which is Alice and Lakers, here highlighted in the blue color. And then you can also have a tuple with a tuple, that is the second tuple contains the first value, which is an atom, Alice, and the second value is a tuple which has two parts, iPod and Apple. Now next data model which we have is map. Maps are very flexible and we can do mapping with them. What that means, you have key value pairs like in a Python dictionary or something. We can have key value pairs, and the first key is typically atomic in nature. That means it is an atom data model, so that you can easily look up various items. And then you can have the value which can be a dictionary, that is a bag, or you can have tuples or atoms, whatever you like. And here highlighted in brown is a map like fan of Lakers iPod and age 20. So moving further, we can have the various conventions of Pig Latin. The conventions and statements in Pig Latin are like the regular conventions of any other language like Java or C++. You can have several multiple lines, and each statement will end with a semicolon, and you can include this various schemas and expressions. And as previously discussed, you have the normal parentheses for marking the tuples, you have the curly braces for marking the bags, and you have the square brackets for marking the maps. And you can have the regular data types like int, long, float, double, etc. Here's an example for word count in Pig Latin. Notice that the minimal number of lines have been used. Here you can count the lines, which are about 6 to 7 lines, and you can also see the declarative syntax using keywords and primitives like load, for each, generate, flatten, filter, group. So you have the declarative syntax of SQL, and you can also make procedures and functions like how you want them in MapReduce. Moving on to the features of Pig. Features of Pig include the data flow language Pig Latin, quick start and interoperability, nested data model, UDFs as first-class citizens, parallelism, and debugging environment. You can have the Pig Latin as a data flow language in Pig and quickly create and learn how to create MapReduce jobs with the flexible features of Pig Latin and the nested data models, that is the bags, tuples, and atoms and maps. You have quick start, that is, you can quickly learn this simple language and run it with Apache Pig, get a whole bunch of MapReduce jobs which can directly be sent onto the Hadoop cluster. You don't have to change anything on the Hadoop cluster. All you need to do is get Apache Pig and a script in Pig Latin, which is then compiled and executed as MapReduce in the Hadoop cluster. You don't have to get any other installations and any other dependencies for the cluster. You also have UDFs, which are very flexible, the user-defined functions, which you cannot easily integrate with MapReduce, but with Pig Latin, it is possible. And you can run these jobs parallelly on the Hadoop cluster, which shows concurrency. And you have the debugging environment. Now, Pig is an open source framework and it gets continuously updated, and with contributions from across the world, you have a debugging environment in it also. However, there are some criticisms of Pig, like database management systems with the classical approach of SQL and MySQL, PostgreSQL. You can get faster data analytics and once the data loading is done. But however, with the MapReduce system, you can do faster loading, and as a result, your data analytics will get easily visualized and the output is generated very fast compared to regular old database management systems. And Pig Latin fits very naturally into the pipeline paradigm. Its ability to include user code at any point in the pipeline is very useful for pipeline development. Among several open source contributions, we have Pigpen and Grunt Shell. Pigpen is where you can find several user-defined functions from contributions, and you can also run your Pig scripts on Grunt Shell. And as a result, we can analyze both structured and unstructured data. Structured is the one which we have in tables and databases. Semi-structured is like the semi-structured formats like XML and JSON, and we also have unstructured data that can even be a text file. Pig is easy to learn, read, and write. It has less complexity and very less prerequisites. You only need to write a few lines of code which can then be converted by the compiler in the Apache Pig into a MapReduce, and Pig Latin takes into consideration the best of both SQL and MapReduce. The applications of Apache Pig are diverse. We have an interesting usage, that is the collection, analysis, and visualization of enormous datasets resulting from web crawls, search logs, and click streams. These are done on a regular basis by companies like Amazon, Google, Microsoft, and Yahoo, and Pig Latin simplifies it. You have very large data sets from web crawls, like you have so many indexes, you have so many web pages through which you need to search, and various terms which per second new users come and put it on the search engine, and you can analyze these search results. You can combine these data sets and get various kinds of visualizations with the help of Pig, and Pig, Apache Pig simplifies this thing. I hope you learned something new from this presentation.